Okay guys, this is the session for worksheet 10, which is, now things are starting to be a little bit complicated and he's not so clear in what the questions are. So I'm gonna do question number 1, but I'm gonna do question number 1 from worksheet B, because the one from worksheet A is very complicated, but the idea or the concept is very straightforward. What he wants you to do, he wants you to integrate this x squared z ds, and remember the ds here, from point 0, 6, minus 1 to point 2, 8, 0. Now, in order for you to know, it's a line segment, so evaluate the integral where the curve is a line segment, so it's a line segment joining the 2 points. Okay, the trick here is to figure out the curve. Now, I want the curve. If you plug 0 in the curve, you get 0, 6, minus 1. And if you plug 1, you get 2, 8, 0. Now watch. If I put for the first one 2t, what happens when you plug 0? Gives you 0. What happens when you plug 1? Gives you 2. So the first one is 2t. Second one, let's try 6 plus t. Plug 0, gives you 6. Plug 1, it doesn't work, gives you 7. So maybe we need to change this to 2t. Now plug 0 gives you 6. Plug 1 gives you 8. It works. The last one, t minus 1. If I try t minus 1, plug 0, minus 1. Plug 1, 0. So this could be the curve from t0 to t1. Now, since they want you to integrate this, what you need to do is to figure out what ds. And the ds, you take the derivative of the curve, which is 2, 2, 1, and then you get the magnitude. ds would be the magnitude of the derivative. 2 squared, 2 squared, and 1 square root of 9, 3. So your ds is 3. I'm going to erase some of this. Now we're ready to integrate. Watch. X squared, this is x, so 2t squared. Z, this is z, t minus 1. ds is 3, and your integration is dt. This is 4t squared times t, 4t to the power 3. 4t squared, and this would be negative 4t squared. And the 3 is constant, you can put it outside. And this integral from 0 to 1. you can integrate 3 constant. This one is T4. This one is 3 over 3, 1 and 0. Plug the 1 minus 4 over 3. Plug the 0, gives you 0. This is 3 over 3 minus 1 over 3 would be minus 1 over 3. So the final answer is minus 1. This is the answer for question 1B. Okay. They give you, do the integral. This integral, this is question 2A, worksheet 10, of course, 2A. Question was to integrate line segment, so still with the line segment, from point 0, 0, 0 to 1 minus 1, 2. But they don't give you the information in terms of ds. So the first one was, remember, x squared and ds. This one is not ds. This one, they want you to do this, x squared y dx, x minus z dy, and xz dz. And first of all, since there is no curve given, first step is you need to determine the line segment, you need to determine the curve. If you plug 0, you get 0, you plug 1, you get 1, so it's t. You plug 0, you get 0, you plug 1, it's minus t, and 2t, where t is between 0 and 1. But remember, there is no ds, rather they give you dx, dy, dz. So what you need to do is you find the derivative for this. The derivative for t is dt. And this will be your dx. Derivative of this would be minus dt. And that would be your dy. And the derivative of this would be 2 dt. And that would be your dz. So now we put everything in the integral. You're integrating x squared y dx. X squared y dx. X squared is t squared. And minus t and dx dt. That's the first integral from 0 to 1. Plus, we'll do integral 2. X, which is t, minus z to t dy is minus dt and 0, 1. That's the second integral. We'll do the third integral from 0 to 1. X is t, z is 2t, dz is 2t dt. The first one is negative t cubed, and the integral is t4 over 4, 0, 1. And that would be negative 1 over 4 minus 0. So the first answer for the first integral is minus 1 over 4. For the second integral, you have minus here, minus t, so that would be minus t2 over 2, minus minus plus 2t. So plus 2t would be t squared, and 0, 1. Plug the 1 minus half plus 1, plug the 0, 0, answer is half. So the second answer is half. And for the last one, you're integrating 4t squared would be 3 over 3, 1 and 0. Plug the 1, 4 over 3, plug the 0, 0, 4 over 3. So the final answer is minus 1/4 plus half, which is 2 over 4, plus 4 over 3. That will give you 1 over 4 plus 4 over 3, which is 3 over 12, 16 over 12, 19 over 12. So the final answer is 19 over 12. I'll do one more for the line segment. I'll do question 2b. They give you this again, x squared y dx, xz dy, xz dz. And they tell you it's from 0, 0, 0 to 1, 1, 1. But this one, they don't want you to figure out the curve. The curve is given. So this time, they give you the curve. And since we don't have ds, we only have dx, dy, dz, we find the derivative. This derivative would be 2t dt. This would be your dx. This one is dt. This would be your dy. And this one would be 3t squared dt. And that's your dz. Now you're ready to do the integral. And it's obvious that you're going from 0 to 1. X squared would be this squared, which is 2 to the power 4, times y, which is t, and dx, which is 2t dt. That's the first one. Second one, 0, 1. X minus z, t squared minus t cubed, dy meaning dt. And the last one, which is xz, t squared t cubed, and dt would be 3 t squared dt. Here you're integrating t to the 6, and that would be 7 over 7, 0, 1. Here you're integrating t squared, which is 3 over 3, and this one is 4 over 4, 0, 1. Here you're integrating t to the 7, 8 over 8, 1, 0. When you plug 1, gives you 2 over 7 minus 0, so the first answer is 2 over 7. You plug 1, gives you a third minus 1/4. Plug 0, 0, so plus 1/3 minus 1/4. You plug 1, 3 over 8 minus 0 is 0, plus 3 over 8. You can leave it as it is. You can try and find the common denominator for the answer, but it doesn't matter. Just leave it as it is. Or if you put them all in the calculator, so 2, 7, 1, 3, 1, 4, and 3 eighths. Gives you 125 over 168. Okay, I'm gonna stop this. This is part number 1, and then we'll continue with the other questions.